Good morning and welcome to Algebra 1. Today we're going to do one more review for our quiz. So I'm going to give you a bunch of problems that are very similar to the problems you're going to see on the quiz, and hopefully that'll all make sense the more we see it. First thing we're going to do is a proof. So here's your proof problem. 4 parentheses, negative 2x plus 1 plus 3 equals 23. So there you go, you can see it now. What I'd like you to do is actually pause the video and solve the problem showing all your reasons. Remember the 4 properties of equality: addition, subtraction, multiplication, division. Also the 2 other reasons we give for what we do: combine like terms and the distributive property. If you could solve this problem right now with reasons, and then obviously begin the film again so you can see the answers as I decide. So pause now, solve the problem, and start up again. Hopefully you actually did that, because I'm now going to explain how we solve the problem. First thing you could do is either subtract 3 from both sides, if you see fit, or you can distribute the 4. It really doesn't matter which one you do. I'm going to distribute first. I think you probably did that. So distribution is multiplication through a set of parentheses. 4 times negative 2x is negative 8x, and 4 times positive 1 is plus 4, and then it already said plus 3 equals 23. Now, what's the reason for what we just did? We distributed the 4 through the parentheses. So we're going to say that's the distributive property. Next up, again, you got choices. I'm going to look at this and say, hey, I've got a 4 and a 3 on this side of the equal sign. They're like terms. I can combine them. What is positive 4 plus 3? Well, that's positive 7. What did I just do? Well, I said it before I did it. I'm going to combine like terms, I said. Combine like terms is one of the reasons for what we're doing. So combine like terms. Like means similar. Okay, great. Now I got negative 8x plus 7 equals 23. I have a variable term here and a constant. On the other side, I have a constant. I'm going to get my constants together by subtracting 7 from both sides. Negative 8x now equals, well, 23 minus 7 is 16. What let me do that? I subtracted from both sides to maintain equality. That's the subtraction property of equality. Yes, you can abbreviate it, but right now, I'm not. Okay, now I got negative 8x equals 16. All I have left to do is divide both sides by the coefficient, which is negative 8. And I get x equals negative 2. What let me do that? Well, I divided on both sides to maintain equality. So that's the division property of equality. Now, was it the only way you could have solved this? No. You could have subtracted 3 first, or you could have subtracted 4 and also 3. But ultimately, so long as you're doing things that are supported by these reasons, you're getting it right. Okay? Next up is an example of a proportion. So here's one with, let's say, 7 over 8 equals 3x over x plus 1. Again, proportions are always solved with cross products. I'd like you to actually pause now, try to solve the problem, and then press play when you're ready to see the solution. Pause now and solve. And here's our solution. We're going to cross multiply. So 8 times 3x, I'm just going to write it down, 8 parentheses 3x, equals the other cross product, 7 times x plus 1. Again, people call it the butterfly method sometimes. 7 parentheses x plus 1. Don't forget the parentheses. It makes it easier to not make a mistake on the distribution we have to do now, okay? 8 times 3x is just 24x. But 7 times x is 7x, and 7 times 1 is plus 7. Now I have a variable term on both sides. I'm going to subtract this 7x from both sides. 24 minus 7 is 17x. And on this side, all I have left is a 7. In order to solve the problem, I have to divide both sides by the coefficient, which is 17. And that gets x equals 7 over 17. If you're really that curious about what 7 over 17 is, well, it's a decimal that doesn't terminate. And if it repeats, I don't see where. 0.41176477059, it just keeps going. I don't want you to round it. It's not a terminating decimal. It's not a repeating decimal that we can see. So I want you to leave 7 over 17. That's the answer. Okay? That's really all proportions are. Cross multiplication, solve carefully. When there is a binomial, which is a two-term piece, make sure you distribute appropriately. Otherwise, there's nothing more to that kind of problem. Just work carefully. When there's fractions, you can leave them as fractions. If they're reduced, that's great. 7 over 17, perfect, no problem. Okay, that's a proportion. Let's do a problem where we clear the fraction. I gave you many examples in class. We talked about it more last week than before. I say we can get rid of any fraction if we just multiply the whole problem by the denominator, or if there's more than one, the least common multiple of the denominators. Let's do a simpler one first. We got 4/3 equals, let's say, 2x. Keep it nice and easy. I want you to clear the fraction. So again, pause, try it, and then restart when you're ready. Pause now. Okay, so in order to clear the fraction, we're going to multiply by the denominator. So I'm going to multiply the entire thing by the number 3. Here's what that does. 3 times 4 is 12, divided by 3 is 4. It knocks out the entire denominator. All I have left there is the number 4. But remember, you have to distribute it to the entire problem. It's the multiplication property of equality. 3 times 2x is 6x. Now, to solve the problem, I divide both sides by the coefficient of x, which is 6. And x equals, you could say 4 over 6 right now, but you have to reduce 4 over 6 because it's a fraction that does reduce. You could factor out the number 2, and we get 2/3. 2/3 is the answer. If you wanted to make that a decimal, it wouldn't be wrong, but you'd have to use the repeating bar over the 6 because 2 divided by 3 is 0.6666666 all the way forever and always. The calculator ends it with a 7 because it rounds it up, but it doesn't actually end. So repeating bar over the 6. If you wanted to clear a fraction that's a little bit more complicated, we can certainly do one of those. So I'll say 1/2 x minus 2/5 equals 3. Now this time we have two fractions with two different denominators. We got a denominator of 2, we have a denominator of 5. I can't multiply by 2 or by 5 because that's not a common multiple of those two numbers. They don't both go into 2 or 5, but what do they both go into? Well, what is their product? 10. I'm going to multiply the whole thing by the number 10. And do it carefully. 10 times 1 is 10, divided by 2 is 5. 5x. Minus 10 times 2 is 20, divided by 5 is 4. 4 equals 10 times 3 is 30. By multiplying by the least common multiple, we've gotten rid of both fractions. There's no more fraction. Now I'm going to add 4 to both sides, and we get 5x equals 34. To solve the problem, we're just going to divide both sides by 5, and x equals, well, 34 over 5 is an improper fraction, but it's not wrong. If you want to make a mixed number out of it, 5 goes into 34 6 times with 4/5 left over. You could also call that 6.8. It does terminate right there, so it's done. Any of these 3 answers are fine. Improper fraction that is reduced, mixed number, which is fine, or the decimal. This time it terminates. There's no problem with it. The only other thing on your quiz are special cases. Special cases are the problems where you've got those 2, let's say, less typical answers, which are infinite solutions or no solution. So here's an example of one of them. We'll keep it somewhat simple. 2 times 3x minus 1 equals 6x. Let's solve the problem together. I'm going to distribute the 2. So I'm going to say 2 times 3x is 6x, and 2 times negative 1 is minus 2, and it equals 6x. So far, so good. I have a variable term on both sides. I don't want that. So I'm going to subtract this one, 6x, from both sides. Now, it turns out that 6x was the term on both sides. So when I subtract it, well, it vanishes from both sides. I got negative 2 equals the number 0. When there's nothing on that side, it's the number 0. Now, here's a question for you. Obviously, negative 2 and 0 are not the same number. They are not equal. That's just wrong. What does it mean when the variable term drops out and the numbers that remain are incorrect, are false statements? That means that there is no solution. There is no number in the real number system that would make this problem true. You can't solve it with a value. There is no solution that would make it true. That's a special case. So what's the other special case? Well, like I said, it's when there's an infinite number of solutions. Let's try this one. I'm just going to adjust it ever so slightly. So it's actually the same problem, except I'm going to call this n 6x minus 2. So when we try to solve it, we're going to do the same thing. We're going to distribute the 2. 2 times 3x is 6x. 2 times negative 1 is minus 2. And on the other side, we still have 6x minus 2. The difference here is that when I subtract 6x from both sides to try to get the variable term together, yes, they still both drop out, but I get negative 2 equals negative 2. It does. Negative 2 does equal negative 2. That's a true statement. Now, the variable term has dropped out. The answer is not negative 2. The answer is that all real numbers will work in this problem. The variable term vanished, but we're left with 2 numbers that are actually correct. So this means that there are infinite solutions. You can spell it out if you'd like, infinite solutions. You could say the infinity symbol if it makes you happy, or the symbol for all real numbers, which is like a cursive capital R with an extra line in front of it. That means all real numbers. So, for today, there's no additional homework. However, tomorrow we are going to move forward. Your quiz is not until Thursday and Friday this week because of our schedule, because of the SATs, because of distance learning. So on Thursday and Friday, whichever day you're in, will be the quiz on this material. So watch the video again if you want to. It will help you. Tomorrow we'll talk about some new content and got to keep moving forward. But on Friday, or Thursday or Friday, depending on your day, you'll have your quiz. If there's any questions, please, of course, feel free to let me know, okay? Send me an email, ask me in class, whatever you got to do. But tell me if you have any issues prior to your quiz. That's all for today. Have a great day.